Hi everyone, in this we will learn about a synchronous binary counter and understand two different ways to control counting. The first approach uses an enable signal inside the sequential block, and the second approach uses clock gating. We will also discuss the advantages of each approach. Let's start with the first design. Here we have three inputs: clock, active low reset, and enable signal. The output count stores the current value of the counter. Now let's look at the sequential block. This block is triggered on the rising edge of the clock or the falling edge of the reset. Since the reset appears in the sensitivity list, this is an asynchronous reset. Next, we check the reset condition. Whenever the reset is asserted true, the counter immediately resets to 0 independent of the clock. If the reset is not active, we check the enable signal. When enable is high, the counter increments by 1 on every rising edge of the clock. And if enable is low, no assignment takes place and the counter retains its previous value. This design is called a synchronous binary counter because all flip-flops are driven by the same clock signal. Now let's look at the second implementation. Here we create a gated clock named G clock. The gated clock is generated by ANDing the original clock with the enable signal. Now let's understand its behavior. When enable is high, gated clock or G clock follows the original clock, and when enable is low, gated clock remains low. Now let's observe the sequential block. Here we have not written explicitly if enable statement because the enable signal is already controlling whether the clock edge reach the flip-flop. If enable is high, clock edges are present and counting occurs. And if enable is low, no clock edge reach the flip-flop, so the counter automatically holds its value. Now let's compare both the approaches. The first approach, which was enable based counter, it uses the original clock directly and it checks enable inside the sequential block. It is simple and widely used. The approach 2, which is clock gating, it reduces unnecessary clock activity and can help reduce dynamic power consumption. However, directly writing G clock is equals to clock and enable is generally not recommended in real hardware because it can introduce glitches on the clock signal. In ASIC design, dedicated integrated clock gating or ICG cells are used to implement clock gating safely. So to summarize, the first design controls counting using an enable signal and the second design controls counting by gating the clock itself. But both the design achieve the same functionality, but clock gating is primarily used for power optimization. Thank you for watching. I hope this video help you understand synchronous counter and clock gating. See you in next video. Thank you.